वेलकम टू फिजिक्स मेड इजी चैनल। आज का जो हमारा टॉपिक है वो वही जो हम फोटोइलेक्ट्रिक इफेक्ट की एक्सपेरिमेंटल स्टडी पढ़ रहे थे वही मैं उसको ही आज कंटिन्यू करूंगा और वी विल कंटिन्यू विद द experimental study of photoelectric effect, and we are at present drawing various graphs and I will just recall some part of the lecture so that you can connect it. So here we have got a source of light and quartz filter here. Cathode is a metal plate which is photosensitive. Light is made to fall on it. Electrons are emitted due to photoelectric effect and they are collected at anode. And current flows in microammeters, so we have attached microammeter here. Voltmeter measures the voltage applied between cathode and anode, and here we have got potential divider arrangement. This is the potential divider arrangement, and this potential divider arrangement is responsible for applying potential difference between cathode and anode. In our previous discussions, we have studied that the effect of intensity of light, on photoelectric current. How photoelectric current flows, electrons are collected at anode and circuit is completed. In this way current flows and microammeter matches the current. So photocurrent is due to the electrons emitted as a result of the fall of light on photosensitive material. Remember, the light should be of suitable frequency such that its energy is more than the work function required. Work function is the minimum energy required to eject an electron without any kinetic energy out of a metal surface. Now, last time I have taught you the concept of stopping potential. Now, effect of potential. Potential is made negative with respect to the cathode. Potential of anode is made negative with respect to the cathode, and we keep on making it less negative and then positive. So for the purpose of analysis, I will start from zero potential. At zero potential, some of the electrons which are having maximum kinetic energy, they are able to reach the anode. So again, from here, all the electrons, they don't have enough kinetic energy so that they can reach the anode. Some of the electrons can reach the anode here. And in my next part, electrons with maximum kinetic energy will be able to reach the anode. Now, as we increase the positive potential, it means electrons are attracted towards this positive anode. So this is positive anode. Electrons are attracted towards anode. This is positive and this is negative. Electrons are attracted towards anode. Now, electrons are attracted towards anode. Here we have shown anode, positively charged. As we are making anode more and more positively charged, here we are increasing the positive potential of anode. More and more electrons, they are able to reach the anode and current keeps on rising. At this particular point, the curves start to flatten out at this particular point. Now the curve flattens. It means at this point, if we increase the value of positive potential, the number of electrons reaching the anode they won't increase and photocurrent will remain constant. It means at this point, all the electrons emitted, they have been able to reach the anode. So this value corresponding to this intensity I1 is called saturation current. And now if we make the value negative like this, then the number of electrons reaching the anode, they will go on decreasing and they will become zero at a particular voltage V naught. V naught is called stopping potential. Stopping potential is that negative volt at which even the electron having maximum kinetic energy fails to reach the anode. So it means this negative potential or stopping potential is the potential that measures the maximum kinetic energy of electron. So this is the significance of this. And at this point, if we increase the intensity here, now I increase the intensity to I2 and then to I3. Now the photocurrent increases. Now this constant value, this maximum value, this particular maximum value for intensity I will represent it by I1. This is I1. I1 is saturation value corresponding to intensity capital I1. Now, intensity in quantum theory is defined as number of I is equal to number of photons small n. I have represented number of photons falling by small n. Number of photons falling per unit area per unit time. T stands for time. Now as we are taking unit area and unit time, it means if I2 is greater than I1, then number of photons falling in case of higher intensity are higher than number of photons falling in case of lower intensity. Now here I have given this order. This clearly represents that N3 number of photons falling in case of intensity I3, they are larger than number of photons falling in case of intensity I2, they are further larger than I1. Means N1. N1 is the number of photons falling per unit area per unit time corresponding to I1. N2 is number of photons falling per unit area per unit time corresponding to I2. Similarly, N3 corresponds to I3. Now the saturation value increases as the intensity increases. Logic is quite clear. If intensity increases, then number of photons falling per unit area per unit time increases. It means more and more electrons will be emitted with increasing intensity. If intensity increases, then number of photons falling increases. With that, there is an increase in number of electrons. Now I will represent this logic like this. If I means intensity increases, then number of photons falling increases. Then number of electrons falling also increases. So intensity increases, number of photons increases, then number of electrons emitted increases. It means saturation current increases with the increase in intensity. Even if you compare at any level, even here, the current corresponding to I3 is more than current corresponding to I2 is more than current corresponding to I1. The variation of saturation current with intensity is, I think, clear. Now, what is saturation current? This I1 is saturation current corresponding to intensity capital I1. Similarly, I can write here I2 is saturation current corresponding to intensity I2, and small I3 is the saturation current corresponding to intensity capital I3. And saturation current. Saturation current, the maximum value of the photoelectric current is called saturation current. This is the maximum value of photoelectric current. At saturation current, remember this line, all electrons emitted by cathode are collected by anode. Now, if we apply negative potential, then when we make the value of V negative like this, photocurrent decreases. It becomes zero at a particular value known as stopping potential. Stopping potential is the minimum value of potential difference between cathode and anode at which the value of photocurrent becomes zero. It is all stopping potential is also named as retarding potential. And this measures maximum kinetic energy. Again, listen this sentence. Stopping potential is the potential for which the value of the photocurrent is zero. Now, value of the photocurrent is zero even when the fastest electron fails to reach the anode. Means stopping potential stops fastest electron from reaching anode. And now let us view it from here. If we keep on making this negative with respect to anode, remember the graph, photocurrent decreases at a particular value of negative potential known as V naught. At a particular value of negative potential known as V naught, even the fastest electron having maximum energy K max fails to reach the anode, and this potential is called stopping potential. And now stopping potential, remember one thing, if V naught is the stopping potential and we multiply V naught by electronic charge, then it becomes work or energy. And this energy is equal to the energy of the fastest electron. It means K max, maximum kinetic energy, according to mechanics, is half mv max square. V max is the maximum velocity. This is equal to EV naught. V naught is the voltage. So this is the mathematical expression for K max is EV naught. This is half m V max square. Now, if we carefully look at the graph, this graph, stopping potential is same. Now, we are talking about stopping potential. V naught is same for different intensities I. Whether intensity I1, I2, I3, whatever may be their values may affect the saturation current, but different values of intensity do not affect the stopping potential. It means stopping potential is independent of what? Intensity of light. Stopping potential is independent of um, intensity of incident light. Stopping potential measures maximum kinetic energy of the electron emitted during photoelectric effect. Now let us proceed ahead. Effect of frequency. We have gone through effect of potential, effect of intensity, now effect of frequency on stopping potential. So for this, now from experiment point of view, now we will vary the value of electric potential as we have done in the previous case. But in this case, we will change the frequency of incident light, nu. So we will change the frequency in this case. Now, let the intensity of radiation be adjusted in such a way that saturation reaches. No, I will directly go to this part. Now, this is the case. In this particular case, intensity I will change the color. Intensity I is same. What we vary? We set frequencies. We draw graph for different frequencies. Nu, different. Once we draw the graph for nu1, nu2 and nu3, we take three values of nu. For first set I take nu1, for second I take nu2 and third I take nu3. Now nu2 greater than nu1 and nu3 greater than nu2. This is the order. Intensity is same. If intensity is same, it means saturation current is going to be the same for all frequencies. But if for larger frequency, larger is the stopping potential. Stopping potential is large for nu3 and then it is smaller for nu2 and it is further smaller for nu1. Now this is the order of stopping potential. As frequency increases, stopping potential increases. So I can write that V stopping potential is directly proportional to frequency. This I have drawn, this is nu. And this is not proportional to intensity, stopping potential. This is independent of intensity, but this is directly proportional to frequency of incident radiation. Now, intensity of photon is given by this. Now if in this case E3 is larger than E2 is larger than E1. Why? Because now nu3 is larger than nu2 is larger than nu1. Due to this, E3 is larger than E2 is larger than E1. Larger the frequency, larger is the energy of photon available. And in my previous lecture, I have explained that photoelectric effect is, I will write it again here. Photoelectric effect is by changing the color. Photoelectric effect is all or nothing. Either whole of the photon is absorbed or photon is not absorbed at all. Another fact. The incident energy of the photon is used for two purposes. One for providing work function, other for providing kinetic energy. So this is the mandatory. Work function is required, mandatory. It is mandatory. Why mandatory? Because without that, electron won't come out of the surface. And the remaining part of this will be used as kinetic energy of electron. So larger the value of incident photon, larger will be the value of kinetic energy of the fastest electron. So if kinetic energy of the fastest electron is larger, it means stopping potential is large. So this is the logic behind this explanation. So what can I say? Now I will write it in code language. If first of all, if we increase frequency like this, it means we increase energy of the photon. It means we increase K max, maximum kinetic energy of the photon. If this increases, it means stopping potential increases. Again starting from here, if frequency is increased, energy of the photon increases, maximum kinetic energy of the photon increases as work function is constant for a metal. It means stopping potential V0 increases. Why? Because K max is equal to E V0. This is the logic behind this. Next part here, we have just indicated, we have just drawn graph between incident radiation and stopping potential. Here along this axis, I have taken frequency. And along this, I have taken stopping potential Vs. Now we have got famous equation, Einstein equation. What that equation is? H nu is equal to phi naught plus K max. I have written just as Km, or you can write it as this. So this is H nu is equal to phi naught plus K max is EVS. We have just done. Stopping potential is that retarding potential at which even the fastest electron fails to reach anode. This was the definition of stopping potential. So from here, this is work function. This is a measure of maximum kinetic energy. So I can take it as y, and from here I can write EVS is equal to h nu minus phi naught, or Vs is equal to h nu minus phi naught by E. If I compare this with this mx plus c, then slope is h by E. Slope is h by E and intercept c is minus phi naught by E. Now, intercept this is c is minus phi naught by E. So this represents c minus phi naught by E, and this represents along this axis is stopping potential. And the remaining part of this, and the remaining part we will in my next lecture we will do the remaining part, and I will start from here, from this very graph. So this finishes today's lecture. I request to all of you to view these videos, critically analyze it, and comment on the negative aspects so that we can improve it. And if you find it to be good, then kindly share it. Thank you very much for being with us for 26 minutes.